Good day, one and all. Today, we are going to briefly know about AWS Industrial IoT Fundamentals, one of the IoT courses provided by Coursera. Our group consists of three members, myself, Tanvi Jadhav, and my group members, Rohan Gaikwad and Rohit Baikar. So, now first of all, we'll see agenda of the course. So, in week one, we're going to see welcome to the course and getting to know IoT and industrial IoT. In week 2, we are going to see AWS IoT services. And in week 3, we are going to see industrial machine learning and working with data. And finally, we are in week 4, we are going to see security on AWS. So now in week 1, you may be familiar with IoT devices and terminology, but when we put that extra keyword industrial before IoT, the discussion evolves. So, while you may be familiar with smart homes and connected appliances and wearable health monitors, you might not know how IoT plays a part at industrial level with assembly lines and supply chains. So, in this course, we will follow a scenario. Let's say you get hired at a manufacturing company that manufactures the best selling cupcakes and donuts. Kids love these donuts, adults love these donuts, and the demand is so high the company often sells out and can't keep products on the shelves. To solve this issue, the company CTO has a vision to adopt Industry 4.0 practices and use the AWS cloud. Your company got into a multi-year agreement with AWS to help them transform and innovate. And they are hiring lots of people with an IoT and cloud background. You being one of them. The company needs to upskill all the employees they are hiring and reduce the knowledge gap needed to build an industrial IoT solution. And you want to be at the forefront of all of this. And this course will help you get there. We'll also discuss some of the key AWS IoT services such as AWS IoT Sitewise, AWS IoT Core, and AWS IoT Greengrass further. So now evolution of IoT. So now we have to talk about the history of the industrial world before we can fully understand the present and even the future. So let's talk about how we got to here. See Industry 1.0, or what's often referred to as the first industrial revolution, happened between the late 1700s and early 1800s. During this period of time, manufacturing evolved from people focused manual labor to optimized labor, labor through the use of water and steam powered engines. From there, the introduction of steel and use of electricity in factories created Industry 2.0, or the second industrial revolution around the early 20th century. This enabled manufacturers to increase efficiency through assembly lines and mass production. Then, in 1950s, we had Industry 3.0, or our third industrial revolution. During this period, manufacturers began incorporating more electronic computer technology into their factories. They also experienced a shift that put less emphasis on mechanical technology, and they also experienced and more on digital technology and automation software, which leads us to present day where a fourth industrial revolution has occurred, which we often refer to as Industry 4.0. This takes us to of digital technology even further with the introduction of cloud computing, big data, machine learning, augmented reality, autonomous robots, and as you might have guessed, industrial IoT. So now manufacturers are developing and using these new technologies to further increase efficiency, it's yet another optimization. And if you can imagine manufacturing technologies, you can have significant operational challenges such as legacy infrastructure, weak technology, integration, and real time and high speed computing requirements. So, there is a real need for tooling that bridges the performance capability gap. Manufacturers need these capabilities to understand their businesses better. So, how do they get them? Well, through cloud computing. Cloud computing in general is one of the critical pivot points of Industry 4.0, and it enables the use of industrial IoT, machine learning, high performance computing, and more. It's all about optimization. So, the cupcakes and donuts manufacturer can produce more cupcakes, more donuts at a large scale with fewer issues. And now, as the name suggests, IoT enables you to bring the internet to objects or things that are present in our day to day life. Internet coverage is increasing exponentially across the globe. Make it easier to embed communication capabilities into devices like refrigerator or vacuum cleaner or even toothbrushes. Yeah, toothbrushes, but it doesn't stop there. IoT is not only about bringing internet capabilities to isolated devices. With increase of IoT usage, we start bringing up a network of devices that can communicate to each other, forming a new ecosystem that brings humanity greater benefits. Now we'll see some of the parameters of IoT versus industrial IoT. So the first parameter is area of focus. So in case area of focus of IoT is on commercial or consumer convenience, while in case of industrial IoT, it is monitoring and managing systems for high stack industries, defense manufacturing, healthcare, and others. The other parameter is focus development. So in case of IoT, it is smart devices, and in case of industrial IoT, it is sophisticated machines. Degree of application. Sensitive in IoT, sensitive sensors, advanced controls, and analytics. In industrial IoT, simple application with low risk impacts. Security and risk measures. In case of IoT, it is utility centric, and in case of industrial IoT, it is advanced and robust. Interoperability. So, in case of IoT, it is functionally independent, and in case of industrial IoT, it is integration with coexisting legacy operation systems. Scalability. In case of IoT, low scale networks. In case of IIoT, large scale networks. Precision and accuracy. In case of IoT, critically monitored. In case of industrial IoT, synchronized to milliseconds. Programmability. In case of IoT, easy off easy off-site programming, and in case of industrial IoT, remote on-site reprogramming required to support new processes. Output in case of IoT is convenience, and in case of industrial IoT, it is economic growth. Resilience. In case of IoT, it is not required, and in case of IoT, must be automated to support fault tolerance. Maintenance. In case of IoT, it is consumer preferred. In case of industrial IoT, it is scheduled and organized. So the industrial IoT or in or our normal IoT en- encompasses more machine to machine communication with the addition of big data technologies and machine learning. The maturity reached by IoT made the ecosystem expand, meaning that machines were communicating more to other machines, while connectivity and data acquisition are imperative for industrial IoT. So IoT is revolution and industrial IoT is revolution and industrial IoT is evolution. Here are some gains from IoT. Industry internal benefits, there are some external benefits, and there are collective benefits. So now we'll see challenges of IoT and unlocking values of IoT. So unlocking values of industrial IoT are: companies require tools that remove constraints on bandwidth, data residency, and application availability. Companies want to democratize access to their data to get better insights. Then next, companies need to a scalable open data store and flexible ingestion tools. Then finally, companies need to use tools that are future proof. Now, business value of industrial IoT. Here are some points that we can discuss about business value of IoT. The first point is reduce operational overhead, then next increase revenue growth, then improve products over time and make data driven decisions.
Okay, so in week one, we learned evaluation of IoT and the basic fundamentals of IoT. And now in week two, we are going to learn the introduction, the various IoT services, and these are that are the AWS IoT Greengrass, AWS IoT Core, and IoT Sitewise, etc. And also we have done the hands-on exercise by installing the AWS IoT Greengrass software and creating an IoT site-wise gateway. So before going to learn AWS Greengrass, we should know the important topics of that, the things and the devices, IoT certificate. So when we're talking about device, a node or a sensor, it means that we are talking about a real hardware component with communication capabilities such as a microcontroller with a sensor. And at the other hand, when we're talking about a thing, it means that we are referring to the virtual world, virtual representation of that hardware in the cloud. Means the thing is a the device is a real hardware and the thing is a logical representation of that hardware in the cloud. Each thing should have a unique name and a set of attributes, and it is associated with an IoT certificate. The certificate material goes inside the device, and AWS IoT certificates are associated with an IoT policy, and all this communicates with IoT device gateway, and you can do some API call to manually provision a thing such as creating thing, create certificate from CSR, create policy, attach policy. Up to doing all that, you can add the certificate material to the device. Industrial IoT needs to operate things at scale. So instead of doing manual API calls for everything provisioning, there are more sophisticated ways to do all this through bulk actions. Next slide. So here we are at the IoT Greengrass. AWS IoT Greengrass is an open source software. This service is built for operating across different platforms such as x86 and ARM architecture on different Linux platforms or as a Docker containers. It requires at least 1 GHz of compute and 96 MB of RAM. This service is also qualified on hardwares from different silicon partners. In terms of feature set, AWS IoT Greengrass supports local data processing, stream analytics, and machine learning on the edge. Even if there is no cloud connectivity, the intelligence operations on the factory plant can continue. Yes, even there is no cloud connectivity, you can continue. Greengrass is designed to offer at least 99.9% SLA, that is critical for connected factories. Next slide. So Greengrass has two parts. First, an edge runtime, that is an open source software under Apache license. This can be installed on the industrial gateways on the factory plant. And the second one is a counterpart that helps you to manage the edge runtime along with the developing and deploying custom applications from your organization. AWS Greengrass brings some great features, thus include a set of pre-built software components developed by AWS, access to local resources such as a serial interface or we can say GPIO, tools for local software development on your local machine or cloud environment, and at the end, advanced feature to maintain a large fleet of devices. So these are the feature of AWS IoT Greengrass.
Week 3. This week introduced to machine learning on the edge and how to apply it as a service in the industrial space. Next, we learn about AWS services that can be used to process data that's ingested from your industrial IoT architecture. Lastly, we get hand-on and create an AWS IoT site-wise monitor portal to view and analyze operational industrial IoT data. Advantages of machine learning at the edge, latency and bandwidth, availability, and data privacy. Week 4. In the final week, this course, we learn why security plays a virtual role in the industrial IoT landscape. We learn about zero trust manufacturing for IoT device security and explore AWS integrations and features for industrial IoT security. Lastly, introduced to security best practice for implementing industrial IoT solutions. Zero trust manufacturing, the core principle of implementing zero trust mechanism, here they come, secure all communications, enable traceability, protect data in transit and at rest, and apply security in all layers. Secure all communications, network location alone doesn't empty trust. Historically, OT environments have been air-gapped systems with perimeter security as the primary defense mechanism for such networks. Enable traceability. Traceability is a key is a maintaining and operating secure industrial network. An enterprise should monitor, alert, actions and changes to environmental in the real time. Protect, protected at rest and transit. Data is secure by classifying it into sensitivity level such as encryption, tokenization, access control whenever appropriate. While data classification is not as commonplace in the manufacturing industry as compared to financial and healthcare. Apply security at all layers. Apply defense in the approach by incorporate security at all layers. For example, OT network, the virtual private cloud in AWS cloud, edge network, computer, instance, operating system, application, and code. Next slide, please. Security in AWS. Industrial perimeter zone architecture with edge gateway. In this scenario, The cell or area zone defines the trust boundary, where devices are allowed to communicate and in the real time, but traffic leaving or entering the cell or area zone is subjected to inspection. Now let's talk about the second typology, which is securing network connection from edge gateway to cloud. The best practice to secure the cloud connections to keep the network traffic private and encrypted. ISA 95 Industrial Edge Architecture. Such tool can also help collect additional information such as logs and metrics from the industrial control system such as MES, SCADA, and Historian. Next slide, please. Security in industrial IoT. This defense in depth posture is based on three different elements, which are people, technology, and operational method. Starting with the people, in an organization, it is always a good idea for people to aware of how serious and important information security is. Now, the technology, when speaking about industrial IoT, I usually divide this into the DID procedure of the factory and the DID procedure of the cloud. The third element is operating mode and procedure. This mostly includes the set of best practice that should be performed by the local IT administrators and the cloud staff. Well architecture framework pillars. The well architecture framework is a framework created by AWS that contains five pillars, which are reliability, performance efficiency, cost optimization, operational excellence, and security. The security pillar contains some guidance regarding the maintenance of access control listed permission-based practice, such as the adoption of the principle of the latest privilege, meaning that if someone doesn't need access to something, they shouldn't have such access. Next slide, please. This is our completion certificate. Next slide, please. Next slide, please. So we conclude that we completed our 4-week industrial AWS IoT course and have a good experience while doing this course. Thank you.